I don't always think it's appropriate to use data to make decisions.
I agree.
Like, I think a lot of the times, like, it is just an impediment. Trying to wait for the data is sometimes an excuse for not making confident decisions about what you want to do. Mm-hmm. If you want to execute in a domain, don't wait. Just do it. We are live.
Hi, Brian. Welcome to the Data Scientist Show.
Thanks, Daliana. Glad to be here.
So Brian is a data science manager. He previously worked at Facebook and Indeed as senior data scientist and machine learning engineer. Brian specializes in ad system design, ranking, and A/B testing platforms. Brian, very excited to have you on the show and talk about your career journey.
Thank you very much. Glad to be here.
So I know you didn't study data science in college. What did you study?
So I guess when I was in undergrad, I guess there was not yet any programs in data science per se, but nonetheless, I didn't study anything having anything to do with data science or statistics or mathematics or computer science or really science at all. I was, as an undergraduate student, I took my first semester, I took a math class, and I did pretty well. And then my second semester, I thought I could take it easy. And I did very, very poorly in my second math class in college.
Yeah.
And that convinced me basically to kind of like give up and focus on other things. And I don't know if it convinced me to give up. I guess I felt more like there was a lot of other things that I was just interested in. I think I've always been somebody where whatever I'm doing, I managed to get interested in that thing. And so there was a bunch of things that I felt like I was more interested in than the rigors of mathematics and science and things like that. So I ended up studying history and Chinese. And I studied abroad in China. I studied abroad in Siberia.
Wow.
I had a very different kind of undergraduate experience than a lot of my peers, especially the peers who were doing degrees in physics or mathematics and things like that.
Right.
And I really enjoyed my time. It was a great experience. And, you know, the beginning of my career had nothing to do with data science. So.
Oh, that's really cool. So when you started to study data science in grad school, what was it like for your transition? Was it difficult?
Yes, it was extremely difficult. So I guess just to give a little bit more narrative here, I moved to China and I lived in China for about 4 years. And during that time there, the thing that I focused on more than anything else was as a linguist. I was a translator, actually I kind of went the full journey from being a tour guide on the Great Wall as an intern.
Wow.
And an English teacher part-time, another internship at a law firm, and eventually became more and more comfortable in Chinese and eventually started working as a translator. And then taking advantage of the fact that I was competent in the language, I began working as a consultant because I was somebody who could be on the phone with Chinese businesses and asking about their manufacturing capacity.
Yeah.
And I took a lot of pride in that. It was like a totally different sphere than I am now. And I had colleagues that would then take this information that I would aggregate, and they would basically begin to enter it into Excel.
Yeah.
And that was probably the first time I had used Excel since like middle school or something like that. And I was, in the process of becoming kind of like the Excel monkey, entering in things, running really simple analysis, looking at the market capacity at the time I was studying wind power. And my colleague who was sitting right next to me, Xu Peng, he was our database guy. He knew how to go. He was like the advanced person. He was basically taking these simple sort of Excel analyses and going the next level up using Microsoft Access databases. So I took a liking to that sort of stuff and became interested in how SQL worked and how to do joins. And it was just like mind blown. It was just like a very, very different world for me. And starting around that time is when I began to feel like I wanted to re-educate myself in a technical capacity. I really wanted to kind of redirect myself towards science. And also I wanted to be able to I was thinking about what I would do after I was no longer living abroad, because it was hard for me at the time to imagine living forever in China.
Yeah.
And I had a lot of people around me that were going back for business school and law school. And I was like, well, what career is mine? What kind of career do I want to have? I didn't want to be just a business school student. I didn't want to just be a law school student. The lawyers I knew, they were very unhappy. And I was fascinated by technology.
Yeah.
So, yeah.
Wow, very interesting career journey. I feel a lot of people like me started their data science journey because we're in we study engineering or math, but I think at some point in our career journey we all feel lost, like why we're learning all the theories. And I think your journey is particularly interesting because you didn't really have the pressure of you have to become a data scientist. You just let whatever you were working on led you to this career journey, which is very natural. And then you kind of just followed your curiosity, which I think is very beautiful.
Yeah, I'd say curiosity plus incentives, right? Like from the perspective of working in a non-technical job,
right?
I think I always had a degree of admiration and even envy towards people who seemed to be working on things where they had engaging, challenging work, a really good work-life balance, and an opportunity to kind of work at the edge of knowledge.
Yeah.
Had to be doing things that were kind of like at the forefront. And so I think I kind of put two and two together, sort of looking at. And I remember reading a lot of answers on Quora, like what is the lifestyle like for somebody in this profession? What is the lifestyle like for somebody in that profession? And I guess I began to kind of gravitate towards technical professions. So,
and now you're a data science manager. So, Quora style question: what is it like to be a data science manager?
Well, it is like adding a lot of paperwork to being a data scientist. I guess I think of management in general as being a process of learning how to work with people as being the, how can we say this? The way that you're expressing yourself is no longer through code. It is through processes. It is through the expression of your team and what your team is sort of accomplishing. So understanding how to work with people and how to understand people. And I think leading with a capacity of like human psychology and things like that. It's obviously it's a different sort of set of skills and a different set of perspectives than I think that are involved in more technical work.
Yeah. And being a data science manager today, what are something you learned from the perspective of a manager that you wish you could have known when you were when you were a data scientist?
Well, I think maybe something to keep in mind, or something I do think of, is the data almost never speaks for itself. I think that maybe there's a bit of belief or a faith that like if people only knew or were exposed to what I was exposed to, they would reach the same conclusions I reach.
Right.
And I don't think that's true. I think it really is important to sort of think about communicating your conclusions and communicating your assumptions extremely early in a process.
Yeah.
And I think that even with professional projects of any sort, it is extremely helpful to be upfront and communicate your assumptions and your limitations in advance. And that's the sort of thing that I think maybe becomes absolutely essential as a manager, but is also something that's really helpful for people that are working as technical ICs.
Yeah, that's a great point, because some challenges I had when I was in my early career was I always only want to present my results when I complete that. I want to make sure the charts are pretty and everything, but then at that point, maybe my manager or the business have already changed their goals, or I didn't correctly understand what it wants from me. But then I went all the way into that, right? And then I wish I could have showed them results when I'm 25% of it or 50% of it, even if they don't really care whether your charts are pretty, you have a lot of certainty, but have this periodical check-in with your manager is very important. And then learn to be comfortable with the uncertainty in the results.
Yeah. I think that's really true. Being comfortable with uncertainty is probably one of the biggest lessons that we can have in life in general, let alone in our careers. I think that's really important. I think especially coming from a technical disciplines, like there is, we are probably often accused by our product managers that we work with that we want to wait until things are actually perfect to move on. And I think that's a fair criticism because things are never going to be known all the way.
Yeah.
And like we have no choice but to act with uncertainty.
Right.
And I think that being comfortable with that and recognizing that up front is probably the sign of of beginning to grow in maturity in one's profession.
Yeah.
One more kind of thought on that is that sort of these check-in points and they need to be sort of flexible and they need to understand that. But along with that is understanding that the need for that work to be part of a narrative that is being crafted.
Right.
The sort of what I found is the more senior in leadership you go, the more things become narrative driven. People are really trying to drive towards an underlying narrative and less of this exploratory analysis. Leadership is not conducting exploratory analysis. Leadership is attempting to sort of to inform a narrative, to create a narrative that hopefully is driven by empiricism.
Yeah.
But they want to basically test a working philosophy, a working theory against the reality of data.
Yeah.
So keeping in mind that your work is always going to be contextualized in some narrative process, I think is really important.
Yeah, that's a great point. I also notice the same thing at work. And sometimes what's challenging for data scientists are what if your higher management leadership has a narrative that's kind of wrong, but they're deeply believe in that and they just want you to find a data point to validate the narrative. And how do you approach the situation? How do you tell them, hey, the assumption you have is wrong?
Yeah, that's a good question. I don't think there's any 100% correct way to do that. I do think there are some good guides. I don't know if you've heard of a book called Crucial Conversations.
Yeah, I think I read a summary of it.
Yeah. So basically it's the art of disappointing people. And that's something that we have to do a lot of the time. And I often feel like the role of a data scientist is to be disappointing. And it is important that we do that kind of honorably, right? Much of our role is to be somebody who bursts the bubbles of other people.
Yeah.
Is to basically take what is just a narrative, an unsubstantiated narrative, and poke holes in it.
Yeah.
Right. And test it. And that rigorous testing is where if things really hold up after that testing, then we can act on it.
Yeah.
Right. Then we have the confidence to begin to kind of approach things with a high degree of rigor and a high degree of speed and velocity and things like that. So I think that it's tough. Every organization refers to themselves as being a data-driven organization, right? But what does that mean? I mean, everybody paints charts to make themselves look great, right? And everyone is sort of tooting or singing to the same tune about what they say they do. And maybe the truth is that instead of, I for instance, sorry, I'm backing out here a little bit. I don't always think it's appropriate to use data to make decisions.
I agree.
I think a lot of the times, it is just an impediment. Trying to wait for the data is sometimes an excuse for not making confident decisions about what you want to do. If you want to execute in a domain, don't wait. Just do it. Do it and see what happens. Just experiment and iterate.
Yeah.
But I think that when you are kind of at the maybe understanding or at that research phase, attempting to sort of like hypothesize about whether your model is correct, or like whether your understanding of an ecosystem is correct. That's the time to sort of put on that scientific hat. But that scientific hat might be a different hat than the person who's executing, the person who's sort of operating in the domain. So as far as like how to sort of present negative findings, I hope that we can be part of organizations that welcome negative findings, that welcome that testing. And I think that, part of the role of a data scientist is to help build that sort of build that culture in an organization. So I don't think there's an easy solution, but I think that it is partially why we exist as a profession.
I think you mentioned a very good point, which is sounds counterintuitive, that we shouldn't always look for data to make decisions. That reminds me of the anecdotes that I think Google, when they tried to test the right shade of blue, they did, tens of A/B testing to find the right shades of blue. I think if you know what you're trying to optimize, you can use data, use experimentation to find the optimization. However, you will never able to build the next, the idea of the new iPhone, the new, whatever it is, through A/B testing, right? Because it's so new that there's no data in it. That's why you have to try and fail. I think that's a very important point. So sometimes if you're just looking for data, then there's no room for innovation.
Right. I think that's true. One of my, I think this is somewhat apocryphal, so I haven't yet substantiated this with actual research, but I know, for instance, that increasingly shows that are released have been designed based off of criteria. So, for instance, they've been cast, their plots have been chosen, their sort of key aspects of like a television show have been chosen through data science. And what I find is that it doesn't make good art. It is. There is something that is the gestalt, which is a fancy word for basically saying like some things are more than the sum of their parts. And it is extremely difficult to encapsulate like lived experiences or very human experiences or rapidly changing phenomena through the sort of like careful measure. I tend to just be somebody who's I'm shy about making predictions of sort of human systems. Like the weather, sure, let's predict the weather. We can get incredibly good at predicting the weather, and we should do everything we can to do it, right? But whenever we're dealing with something where there's a human in the loop, we are dealing with something that is, and this is getting a little bit nerdy here, but anti-inductive. So the idea of induction is that if I know what happened yesterday, that gives me a good idea of what happens tomorrow. Proof by induction, right? N implies N+1, right? But when you have a human in the loop, you have a specific result of N+1 knows about N. It knows what it's predicted to do. And it will incorporate that knowledge into the future. And that's like fundamentally one of the problems with predicting markets or predicting recommendation algorithms or trying, for instance, to detect anti-vaccine sentiment. Because as soon as they know what's detected, they'll use a new thing to disguise their behavior.
Do you have any example in your life that you... like a lot of other people are using data to make decisions, but you followed something else?
That's a good question. I mean, generally, I believe that a lot of things can be improved through data. I guess I feel like a lot of people count calories, for instance. I'm fairly comfortable just eating with like principles. I don't necessarily need to adopt a highly rigorous or data-driven approach. But I think it's a good question. I don't know. What about you?
I'm thinking about the decision from when I live in China, moving to US, picking a university and then moved to Seattle, then now living in San Francisco.
Yeah.
So the rational decision would be maybe looking at how many jobs those cities have or median income, or I don't know if there's an index of happiness, but I never really follow that. Of course, on a high level, no, those cities are big cities. They have a lot of jobs and opportunities. But a lot of the time, I just kind of follow my intuition. Hey, I want to move to that city, see what happens. I think, of course, if you ask me how do I invest in stocks, how do I manage my wealth, I will definitely look into the data. But I think a lot of our life decisions, there's this sense of adventure, or when people either say follow your heart, follow your intuition, or whatever. I'm not really following the data.
Mm-hmm. Yeah.
And I don't like it when people always say, oh, you're a data scientist, you should make decisions and this and that.
Right.
No, I'm a person.
Yeah.
I have a job as a data scientist. I know how to use data to solve problems. But data itself has a selection bias, right? There are a lot of things cannot be measured. And if you're only using data, you're ignoring those things cannot be quantified. So that's my thesis.
I think that's a wonderful thesis.
Yeah.
And, I mean, just to make that very concrete, there's this whole idea of the paradox of choice.
Exactly.
Like if you spend all of your time evaluating the thousands of solutions and you choose some methods to select the best solution, oftentimes people are less satisfied with their choice, right? So I think it's totally true that there are domains in which the attempt to use data is actually kind of a fool's errand because it actually makes us less happy.
Yeah.
I think that's...
Isn't that like ironic to data scientists talking about not using data to make decisions?
Right.
But I think it's just because we under data so much. We see, the good, the bad, the ugly. So it make us keep thinking about that.
Well, hopefully somewhere there's two artists talking about how sometimes they need to be rigorous. Sometimes they just trust the science.
Yeah.
Right? Yeah.
Uh-huh. So going back to the culture you talk about, I'm very interested in what do you think about, for example, if a data scientist working in a company that doesn't have a good culture to listen to the data science, to really drop the bias and be open to objection of their assumptions. So if a data scientist working in that type of environment, besides asking them to quit their job, how do you think they can change the culture?
Well, I guess the first thing I think I would do is I would have a conversation with whoever hired me. Like, why am I here? Like, what do you want from this, right? And that can be potentially a hard conversation because maybe what they imagined is somebody who would just execute on what they thought was true. Or maybe they just wanted somebody who would, write the SQL.
Right. Be the data monkey.
Right. Be the data monkey, right? In which case, there is a role for that, right? You can sort of I think that one can directly question, well, okay, I accept that this is how you conceived the role. However, I think there's ways for me to be more useful. And one of those ways might be testing some of these hypotheses or investigating these assumptions. And it's not necessarily true that that's always going to be welcome. And I think that can be a hard lesson sometimes, right? But I think that probably it's to the benefit of anybody in their career to really understand what's expected of them.
Yeah.
If it really is just that simple that they're expected to play that, that data monkey role, then that's good to know early, right?
Yeah.
And hopefully you can find yourself either joy in that position, or you can find yourself to an organization that shares your concept of how to do things. So, I mean, I don't know if there's a surefire answer to that. I can definitely imagine points in one's career where one would want... I just think that basic clarity is the first thing that you'd want.
Right.
And having a sincere conversation with leadership about what are their expectations and are they open to other ideas.
Yeah, that's great advice. So when I look at your resume, when you were doing grad school, you studied data structure and algorithms, kind of some curriculum more in like a computer science major. So how do you feel, did that help you become a better data scientist?
I would say yes, absolutely. Now, I think that we are talking about data science as if it is a specific thing, but
Right.
it's really not, right? Within the entire domain of data professions, there's an incredible variety.
Yeah.
There's how I started with any sort of data, I was simply using Excel to conduct very, very silly analyses and basic analyses. Then I was writing SQL. Then I was, learning the very basics of statistics. There's all these other terms for sort of related professions. There's data engineer, there's machine learning engineer, there's data analyst, there's statistician as a separate profession.
Yeah.
There's A/B test, like you could talk about a testing lead or an A/B test infrastructure, right? All sorts of different dimensions. And I basically think that if you're going to be really, really, really broad and take the perspective of all of the things that pertain to data science, I mean, basically it's everything. I mean, you could even include web front end if you're talking about data visualization and things like that. But I do think that there are some things that get hit on a little bit more consistently than others. And I do think that knowing about data structures and algorithms, runtime, the computational complexity associated with solutions to problems is one of those things that, at least in my career, I've seen pop up over and over and over again.
Yeah.
And a lack of understanding of those things can frequently be a barrier to providing reasonable solutions.
Yeah. So what are some topics that you wish more people have studied in school or by themselves?
I mean, I think it's helpful to know the idea of big O notation, which is like a common computer science, just talking about algorithmic complexity.
Yeah.
I think it's very helpful. A lot of things I think are very difficult to become familiar with in an academic environment, and they really do require a little bit of exposure in industry. But I'll say that in my own journey, coming from a program that was in statistics and operations research with some courses in computer science, the whole environment of distributed computing and how distributed computing works, or any of the tools there, was an enormously steep learning curve. It was extremely hard. I will say it was challenging. It was like a challenge I enjoyed, but it was very, very, very steep learning curve to kind of become adjusted to how infrastructure works, how data infrastructure works.
Yeah.
So I think that even a fundamental familiarity with the tools available and those sorts of things can be a big eye opener. It can demystify how things work.
And then you mentioned it was a very steep learning curve. So how did you maintain your motivation when you were learning that?
So I think about this a lot, actually. And as a manager, I think about this a lot. Like, what is the appropriate rate of exposure to new concepts, right?
Yeah.
Because if you're exposed at too high a rate, you get discouraged. Everyone gets discouraged. There's no one in the world that can just hammer away at an impossible problem and not be discouraged.
Right.
I don't care who we're talking about. And there's also no one in the world that can just do the same thing every day and not get bored or complacent.
Yeah.
So there's some optimal mix, and maybe that optimal mix is different from person to person about what is the appropriate rate of new material.
Yeah.
But for me, it's my own version of the 80-20 rule. I think that one should be striving for between 80 and 85% familiar concepts that you can execute on well, and about 15% of like new things that are challenging. And for me, that was enabled by the fact that I was really paired with a really good engineering partner. So the parts that were new, I had a guide, and I was also a guide for somebody else. So it was a really wonderful pairing.
Yeah. Was it in grad school or in your work?
This was at work. Yeah. So this was at work. Yeah. So I think that having a really good pairing between engineers and data science is like an immensely rich and rewarding experience for both sides.
Right.
I think I think organizations and individuals benefit from that.
Yeah, that's a great point. I also feel when I was working engineer, I learned so much from them. And it actually might be helpful for data scientists when you are at work. It's not just good to have a senior data scientist, a mentor. Try to find a mentor in as an engineer, and you can learn a lot from them, because eventually your data science solution is going to be in production, and it's good to know how they work, how they think, what are their standards.
Yeah.
So,
and I think it's also, just to add a little bit of a footnote to that, it can be really nice to find an engineer who is interested in data science.
Yeah.
Right? Of which there are many. Like there are many, many engineers who are interested in learning more about statistics and machine learning and things like that. So
it's a win-win situation.
It's a win-win situation.
Yeah. And you spend a lot of time working on auction design and analysis. So can you tell the audience what is auction design and why is that important in ads?
Sure. I mean, auctions are a huge area of technology. So let's see where to start with that idea. I think we all have this, we might all be familiar with the concept of a very simple auction where they're auctioning off art or cattle or something like that. And somebody is basically putting the item up and people are bidding against that item, how much they want to pay. And there's sort of I can't remember if that's called an English auction. I think that might be the formal name for that kind, where people just iteratively say the price they're willing to pay and bid against each other. But there's all sorts of different auction designs. There's an auction design is like almost an entire discipline in and of itself, part of kind of a sub-discipline of something called mechanism design, which itself is related to economic game theory and things like that. So auctions are an incredibly important part of the internet. I mean, almost every single free website you used is powered through ads, and behind almost every single ad system is an auction system. And so the study of ads auctions, which are obviously one of the largest scale systems of auctions in the world, and also one of the fastest kinds of auctions you can have in the world, is something that a lot of analytical energy goes into and a lot of engineering energy goes into to making those things work better for the sites that they run on, better for the users that they're helping auction off, or better for the advertisers that are making use of the ads.
And then what type of algorithms or models you use to solve this type of problem?
Well, I think the dealing with ad tech, the fundamental question is, what ads do you show? To whom do you show them? To when do you show them? And how much does it cost the advertiser? So resolving all of those questions is kind of like unpacking unpacking a suitcase where you can never get to the bottom. But like one of the most common components of any sort of ad auction system is a probability of event. Because one of the big powers, or one of the huge differentiators between the internet advertising and, let's say, a newspaper or a billboard, is the ability to be dynamic. Right? We can change this content out depending on who's looking at it. Well, how should we change it out? Why should we bother changing it out? Well, the thing is that we can guide it by the behavior, because we can observe the behavior that somebody has after seeing the ad. So this is the whole idea of click-through rate or the view-through rate and things like that, where we are, thanks to the ability to look at behavior before seeing an ad, while seeing an ad, and after seeing an ad, we can begin to have data on how advertising is actually affecting people's behavior. And we can begin to then make predictions about that behavior. And then you can come up with this whole idea of, well, what order should you show ads? Well, you should show them the most relevant ones first, or the ones that are going to that are going to attract their eyes the most, right?
Sure.
And to some degree, that is both, of course, beneficial for advertisers because they're getting clicked on, right? But also beneficial for the users because they are seeing relevant material, right? There's things like, it's probably better than seeing something totally irrelevant. And I'll say that there's a number of caveats here, because there are totally very gimmicky and negative ways of getting people to click on things, like the clickbait, right? But on average, I think a relevant ad experience is probably a better ad experience than an irrelevant ad experience.
And this sounds like a lot of very interesting problem to solve. So for data scientists who are interested in this domain, what do they, for example, if they're interviewing a role focusing on auction, what type of course or books should they read to prepare for interviews?
That's a good question, but let's take a look up here at the bookshelf and see. I don't want to like just say go read a textbook, but I'll just share some books that I think are kind of interesting. So, and I can't claim to have read all of these, but I'll claim to have at least skimmed them.
The catalog.
Yeah. So 20 Lectures on Algorithmic Game Theory by Tim Roughgarden. Is one that is sort of like viewed as a canonical work. Here's another one that also has him as one of the authors.
Wow, it's a big book.
It's a big book, and I can't claim to have made it very far in this one. And another one, which is
a lot of game theory.
Game theory is like at the core of auctions.
Yeah.
These are both very technical. A book that is not as technical and I think is extremely good is called Who Gets What and Why. And that book is upstairs, but I can't get it. But that is the work of the Nobel laureate in economics, and it's basically him writing a very approachable summary of his life's work, of his research.
Wow.
And this forgive me, but I can't remember the name of the author, but he was the inventor of the med school residency matching algorithm.
Oh, wow.
And he's also the person who co-developed the kidney exchange, the American Kidney Exchange, which basically matches donors and recipients for kidneys. He's worked with law schools and with the regarding the judge matching system. He's basically somebody who like just such a brilliant speaker and writer about systems and incentives and game theory.
Yeah.
I find his work to be really fascinating, and this book in particular is just a wonderful, wonderful introduction to this way of thinking.
Yeah. Wow. I want to read this book now. So you learned so much about game theory. Have you applied to your life philosophy?
Yeah, probably in ways that aren't always nice. Like, all right, so maybe here's one way. When you're trying to plan an event, like having defection is a really bad problem.
Yeah.
Right? So if like people who are flaky, how do you deal with flaky people in your normal life, right? It's really disappointing to deal with flaky people, right? Because you're planning a dinner party and you bought all this food, and then all of a sudden they're gone, and you're like, well, now I have this extra, and they only told me at the last minute.
Right.
Get them to pay first. Right? Get it so that there's money down, so there's pre-commitment to this outcome.
Yeah.
And like find really friendly ways to do it, obviously, or find ways of basically, maybe you could even donate the money to a cause, but you're collecting it up front so that you're making sure that there's a less of a sunk cost for you, and also giving everyone else an incentive to follow through on their commitment.
Yeah.
So that's one maybe very personal example.
Yeah.
Another way, let's see if I think about how game theory is applied in my daily life, is during the pandemic. I was one of those people that kind of did the digital nomading thing.
Yeah.
Right?
You did.
And in one situation, I was living with in a sort of a retreat center. We were at 14 people that were dividing up space in a large property, and we had to come up with a way of choosing which rooms we were going to have. So we knew how much the total rent for the property was, and we knew that people had very different preferences, very strong preferences about this or that they were going to do. They wanted this room, but they didn't want that room. They, felt very strongly about that. So we wanted to find, and I'll credit the organizer Danny with wanting to find a fair way to divide up the rooms and split up costs in a fair way.
Right.
And he researched a game theoretic method of doing so.
Okay.
And it was a algorithm. Oh gosh, I can't remember the name of the algorithm. I believe it was a Chinese American author who developed so-and-so's algorithm for fair division.
Okay.
And so we all put in our relative prices that we priced out what we thought each room was worth as a proportion of the total rent.
Interesting.
And the result was it just spit out the room assignments and no one had anything more to say. And it was just done. So it's just like, it was a very, very good way of splitting things up and creating a fair system of division.
Yeah.
So.
Wow. So data science is useful in real
Yeah,
life.
you can apply it. Yeah, yeah.
What are some mistakes you made earlier in your career?
So talking about this role of the data scientist as the person who's not afraid to disappoint people or not afraid to burst the bubbles of other folks.
Yeah.
I think that there's part of me that really likes doing that. I have a bit of a iconoclastic and contrarian personality. And I actually think that data scientists often have a contrarian personality, right?
Yeah.
They're like, prove it to me.
Right.
I think that is a strength. Like, I think that it's important to have a little vein of contrarianism. Like, we need to be persuaded that things are real.
Yeah.
But I think for me, I embraced that contrarianism a little bit too strongly. And I took a lot of pleasure in the process of saying how other people are wrong.
Yeah.
For instance, maybe too publicly.
Yeah.
Maybe not very delicately. And I think that if I were to go back and caution myself, it'd be like, hey, be mindful, because ultimately you're playing an infinite game with these people.
Yeah.
You're not playing a one-off game.
Right.
You're going to, whatever you say, you're going to have to deal with them tomorrow. You're going to have to deal with them in a year, you know? I think that I would probably say that, like, embracing my inner contrarian or my inner sort of like argumentative side at different points has been a weakness in my career.
Wow.
Yeah.
I just noticed I also made similar mistakes, especially when I also used to work with product managers on A/B testing. And then at that time, I was kind of a little bit like a data tyrant. Hey, your result is bad. You shouldn't launch it. But sometimes maybe there are some other reasons that they do need to launch it. I think it's very tricky. For our role is to facilitate them to make the decision, but you shouldn't say, hey, just because this is the data, then you shouldn't make the decision.
Right.
And that's something I realized a few years later. So for you, the way you talk about it just sounds like you have great self-awareness when you reflect on that. Did you always have that type of awareness, and how did you develop that?
I think through making mistakes and through suffering from mistakes, you begin to reflect on, because somehow your sense of what should be in the world is different than what's happening.
Exactly.
And you're like, okay, well, what's going on here? How is my model wrong?
Right. Yeah.
And the thing is that you wind up realizing that your modeling of yourself is incorrect. Your understanding of how you are perceived is incorrect.
Right.
And I think that's a really big opportunity to kind of reflect. And it's like, so I often do think that failures are one of the blessings there, because it is when you fail, and it doesn't have to be a dramatic, terrible failure. You know, I don't want to recommend anyone have career-ending failures.
Yeah.
But blundering a bit is a way to really learn important lessons. And so I think, fail 15% of the time. Maybe not quite that much, but subject yourself to situations that require you to reflect and require you to learn and adapt.
Yeah.
And I think that, this is something, maybe a larger commentary, like, especially at the beginning of one's career, you will screw up.
Yeah.
And you should. And it's because you screw up that sometimes, eventually, when you recover from your screw ups, it's like everyone, sorry, I keep interrupting myself, but I'm going to say everyone always criticizes technology, or they comment about technology being a domain in which people switch careers very quickly.
Yeah.
2 years, 4 years at a place, etc. Whereas in other careers, working 4 years might be like a minimum. Like they really feel like they have to stay a long time.
Right.
But I think that that's, first of all, a sign of the fact that people are in a domain that is evolving very quickly, but also because there's a way of sort of dealing with institutional memory. Like if you've committed a bunch of mistakes in a place, and I think you should be committing mistakes in a place to learn, then that can be a hard place to then have a group of people that are kind of like confident behind you. So not being afraid or not feeling like you have to be held to the standards of your peers in that particular company is kind of liberating.
Yeah.
Like you feel like, oh, like I've learned so much here, and I've learned through mistakes I've committed, and that makes me feel like I know what to do when I encounter these systems in the future. And maybe by virtue of making these mistakes, I'll be a better data scientist in the future wherever I go next. I'll be a better manager whenever I deal with having a team. And I think that like being able to truly embrace the embrace the chaos to some degree of the fact that like learning's hard, and like career progression is hard, and almost no one's narrative is without failures.
Right.
Almost every single person that you see, I mean, especially people that have had success that you admire, they've crossed bridges to get there.
Yeah.
They've taken risks and probably failed on their way there.
Yeah. And I remember when I was a new data scientist, I didn't have a lot of confidence when I present my results, my analysis. I was so afraid of failure. So how did you build confidence gradually? How did you feel comfortable about making mistakes or looking stupid, asking questions?
Well, I think getting feedback from people early, right? And this is one of the most important things that I think a good manager can do, is a good manager can create an environment where that feedback is actually a gift. Not like it's an opportunity for everyone to get better. It's not a blame game. It's not a place where people are worried about their jobs or worried about their bonuses, right? Creating an opportunity where people are sharing their insights and being challenged by people who respect their integrity and respect the process. And so I find, for instance, that one of the best ways to have confidence about your results when you're sharing them externally is to first subject them to an internal audit. So you come up with a group of people that all have a similar training. And in that group, if you're able to persuade the people in that group, then when they're presented externally, it's going to be like no brainer. Of course, I got it.
Yeah, that's very important. I definitely made I wouldn't say a mistake. I had a presentation to an external team, but I didn't have someone from my team to take a look at that. And then there's an important piece I missed, and then I just did poorly in the external meeting. And then we realized, okay, we need to have this mechanism before we do external presentation. We have each other kind of cross-check our work, not to criticize ourselves, but just kind of because data science is different than just having code reviews. It's similar to model reviews. I think that's a very smart thing to do. Yeah.
I mean, analytical reviews, model reviews. I mean, a culture of review.
Right.
And even a celebration of review.
Like, oh, I love that.
Yeah. Like it should be deeply ingrained as part of the process.
Yeah.
But it's not always easy to build. Like people get very, there's a natural tendency for people to become quite intellectually protective. I think that academia suffers from this a lot. People can be very protective of their results or their methods, and shy about publishing or racing to publish and stuff like that. So sometimes overcoming those kinds of biases can be important in establishing like a truly communal process of like holding each other to higher standards and all sort of opting into a process.
Yeah, that's great. As a data scientist at Facebook, what's your day-to-day like working on ads and A/B testing infrastructure?
Yeah, so I was primarily focused on the very, very narrow domain of looking at the performance of extremely large advertisers and the way that their ads performed in the auction, understanding the sort of inner workings of different auction components, and trying to understand basically what processes or what procedures or what strategies could firms use to further enhance their performance. So it was highly specialized, and it was sort of on this like last end of basically customer orientation in terms of looking at the technical analysis of the auction on behalf of the most sophisticated users of the auction.
Oh, wow.
And then trying to basically trying to be somebody of an intermediary who is there to basically understand, make recommendations about auction functioning, and study the performance of the auction.
Oh, interesting.
So,
what kind of tools did you use?
Oh, all of Facebook's internal tools.
Oh, internal tools.
Yeah. So, as with many very large tech companies, Facebook's internal tooling is quite mature.
Yeah.
I believe that their internal obviously Presto is like is a a very low latency SQL engine, and Presto is used through a front end that I can't remember the name of, which is like an awesome sort of plotting front end where you can just like run SQL queries and have visualizations on them almost instantly. And a kind of cool little tidbit is like Airflow was originally composed at Facebook, but the engineer wanted to open source the project. And Facebook did not want to, apparently.
Oh, okay.
Yeah. And so the engineer decided to leave Facebook and went to Airbnb and basically rewrote the entire project.
Wow.
With the stipulation that they needed to open source it. And so the Airflow, this tool that is extremely commonly used now across industry, was open sourced because of this one engineer who was very stubborn.
Wow.
So I don't know his name, but that'd be a good story to dig into.
Yeah, that would be a good story. It could be someone I interview at some point.
Yeah.
What is your long-term career goal?
Well, I guess I think, as mentioned, I really like helping build out an organization, build out processes, and I guess it depends on what one's sort of criteria are. For me, I think obviously money is a big reason why we work. But it's probably an insufficient, like working for money alone is not usually a very fulfilling thing to line up with. So I think for me, it's a combination of being able to work with a problem space that I find really compelling.
Yeah.
And also work at an organization that I feel like I'm helping build and serve. And, working on something that like has some potential to do, I guess, something non-negative in the world. I don't think that, I don't think all jobs are just jobs. We are part of a very complicated ecosystem of technologies and society. And I do think that what we do matters. And it's not always the case that one doesn't always have the opportunity to work with things that they think matter, right? Like I think that we all make compromises about whether or not we work in alignment with our values or not. But one thing, hopefully, as one's career develops, you have the opportunity to make that decision, right? And I always get inspired by people who seem to be progressing towards their values, towards working in alignment with their values or their passions, right? Whatever that be. So for me, I mean, I truly believe, I don't have any plans to act on this in the immediate future, but I truly believe that like climate change is a really, really like maybe the most important issue of our times. And so if there is room at some point in the future to be effective in that domain, that's something that I could imagine myself being really passionate about.
Oh, wow.
Yeah. I also think that, on the total flip side of things, I think that cryptocurrency and I think that decentralized finance is a extremely interesting and new force in the world. and it has both positive and negative implications, but I think that's a space that is going to dramatically shape the future as well.
Yeah. So how do you see data science play a role in decentralized finance?
It's a good question. Maybe if I had the answer for that, I'd already be doing it. But there's a lot of really interesting computer science and in those domains. I mean, the decentralized finance is all just cryptography. It's applied cryptography.
Yeah.
It's fascinating how these things that seem just like when you're in grad school or when you're taking courses in algorithms and you learn about hashing, it's just abstract. But all of modern secure computation relies on mathematics. I think that's absolutely fascinating. As far as concrete applications, I mean, there's interesting things such as Oracle networks, which are basically using trusted sources of data to indicate the truth or falseness. So, for instance, you could imagine something that is monitoring the rainfall levels, and you have a whole bunch of different hardware detectors that are basically transmitting a signal to a blockchain, and there is some sort of decision criteria that if rainfall exceeds some amount, then something happens, or if rainfall is below some amount, then something happens. That's sort of more in the domain of smart contracts. But yeah, the applications, I mean, as with the domain of finance in general, the application of rigorous statistical thinking to, I guess, decentralized currencies as a marketplace. I mean, that's already been incredibly influential in, creating all sorts of high frequency trading applications inside of the Bitcoin ecosystem and Ethereum ecosystem. So I'm sure that there's tons of applications in those domains. Another domain that using cryptography or blockchain to basically serve as a form of validation that things like an ad impression has been served, and the use in ad tech. I don't think that that's been explored.
Oh, wow.
So I think that there are basically thousands of applications of these technologies that we just haven't seen yet.
Yeah. So besides cryptocurrency, global warming, trying to catch the fly. What are some other things you like to do when you're not working on data science?
Let's see. I try to stay relatively well read, so I read lots of history books, and I try to enjoy life as much as possible. Getting outdoors and going to the parks, going roller skating is a big thing of mine.
Okay.
Yeah, mountain climbing, bike riding, stuff like that. As far as technically speaking, sometimes I make progress through some of these technical books. I really enjoy diving in for a period of time, and then sometimes I can feel like I'm slogging through things, and my pace through a technical book can be very, very slow.
Yeah.
So, yeah.
I think that's normal. It does take time to digest technical books. So, for example, when you are reading a very difficult part of a book, or say at work, you have some stressful situation, how do you handle those times?
Take a break. Yeah, I think taking a break is a wonderful strategy. But also, I mean, it's not always the case that taking a break, that I don't always get back to the thing that I was originally sort of focusing on. I think for me, it's really important to have an application to really motivate it. And so being able to work through something that I feel like is imminently or useful is a good strategy. But yeah, what is that? I just read this on Twitter the other day, which was the best debugger is a walk in the park.
Yeah, or a hot shower.
Or a hot shower, exactly. Yeah.
So I'm curious, who you were when you were a teenager or a kid?
I think I was probably a contrarian nerd. Contrarian in the fact that I really liked to debate. I thought I knew everything. I was extremely willing to like pick intellectual fights.
Yeah.
Not very much physical fights, but intellectual fights. I was all about intellectual fights.
Yeah. But then you decided to study history and Chinese in college.
Yeah. I mean, I think probably I was actually very interested in kind of revolutionary movements and sort of like non-Western history in particular.
Yeah.
Just because I grew up in a town that was a very, very progressive, kind of like a place where people, like for instance, in my high school, there was a fairly large protest against the Iraq War in 2003, I guess is when the invasion happened after September 11th. And I was an organizer. I was a co-organizer along with a bunch of other people of this protest. And so we walked out of school in the middle of the day and, you know, had this sort of activism that we did. So I was surrounded by a bunch of like activist kids.
Wow.
And one of my, several of my classmates went on to become activists in their early 20s. Some were associated with the like anti-coal mining activities in like West Virginia. So there was a very, very large, there was a trend called mountaintop removal in which mountains were basically turned into pits to mine coal. And there was a fair amount of environmental activism in protest of these things. And so that was sort of my peer group when I was in high school. And I kind of followed that interest of kind of like anti-establishment and anti-capitalist kind of, I guess, activism and anti-war activism by wanting to like really explore other narratives in history and like looking at other parts of the world and how things had gone in other parts of the world. So I remember taking women's history. I took a post-colonial Africa, history of post-colonial Africa. Took a history of the Vietnam War. Took a history of Russia since Stalin. So a bunch of fascinating courses. I studied abroad in China. I was very interested in sort of understanding just non-Western narratives of the world, non-American narratives of the world. And I think I got like a lot of really wonderful exposure. And I left college, I think, much less radical than when I started.
Okay. How so?
I think really the big turning point for me was in actually living abroad and living in China. I guess I gained an appreciation for how difficult it is to have good rules or even reasonable rules, like not even necessarily good rules, just rules that aren't crap.
Right.
And to have social norms that are positive or, and I guess I think and this sounds obviously very, I sit here as a white American man working in the technology industry, and like I'm aware of all of those aspects of basically saying that America's great, but like I honestly believe that it's better than it has been for most people ever before in history.
Right.
And that it was actually really hard to get here. Yeah. So I have, I think, a little bit of an appreciation for how fragile positive social norms are. And I think that living abroad made me aware, and for instance, studying the history of the Chinese Cultural Revolution and studying the history of Chinese Civil War, reading about the sort of liquidation of the kulaks in Russia, reading about the experiences of colonization in much of the world. Like, we live in a very unprecedented time of peace and prosperity. Yeah. I think it's actually really unique. And I feel very fortunate that we've been able to create this space for peace and prosperity, even while also believing that it's really important to keep improving it. Yeah. Yeah.
Well, cheers to being less radical. What are we drinking, Brian? What is this?
Oh, we are having baijiu. I need to pour myself a little bit more.
It's so spicy. My dad loves it. It's always like
Yes. So this is not the best baijiu, but this is what we got.
We're drinking this.
Yes, we've got the Arguotou. So, like, I remember learning that Arguotou, literally translated, is the top of the second pot, right?
Actually, I don't know what it means. I just learned something from you.
There we go.
Yeah.
No, I love this piece. This is my little bit of trivia, baijiu
Yeah.
trivia. Arguotou is not a brand. Everyone thinks like, oh, it's a brand.
Yeah.
No, but it's more like a marker of quality.
Okay.
Because in Chinese tea ceremony, it's the second pour of tea is like the best pour.
Yeah, I know that.
Right, because the first one they're washing the tea.
Right.
Right.
Wash the
so
tea.
in baijiu, the first one is considered like too high alcohol content or whatever. So it's the second pot, which is supposed to be the superior quality.
Yeah.
And this is the top of the second
Right.
pot.
Yeah.
第二锅的头. So yeah.
Oh, interesting.
Yeah.
So you spend a lot of time learning all the history. I'm curious, how does it change your perspective in career? Or do you feel you learned something from history, philosophy that helped you to be a better data scientist?
Yeah. And so this is something I actually kind of like to think about. I actually think they're really related.
Yeah?
Right. So hear me out. So, all right, I'm going to wax philosophical for a little bit. So the statistics is fundamentally the science of empiricism. Like, how do we know anything?
Right.
Like any sort of medical trial, anything like that at all is a function of basically distributions and things that we can say with confidence about distributions.
Right.
So the undergirding of every single scientific conclusion is statistical in nature. History, I think, when done well, is also the study of large patterns of behavior.
Yeah.
It often is sort of explored through a specific person's narrative or a specific individual's life.
Yeah.
But honestly speaking, it is the study of human systems, like of society level systems, as they change and as they evolve over time. So I think of them as being very much tied to the similar idea of basically studying patterns in large populations.
Yeah. Yeah.
And there are specific ways where this actually informs it. So, for example, archaeology, which is, digging things up, basically history is sort of, the study of history is divided between the archaeological record, like when you go and actually dig in the earth and what do you find and see, and the written record, which is like, what's written down? What are people saying, right? And these two things don't always line up, right? Like people can write things that is like, we're like, okay, we think you're lying, right?
Yeah.
Or they can either include things and then we're like, well, now we have a clue. We can go over here and dig and see if we can actually find evidence of this thing. So there's a very big interplay between the archaeological record and the written record of a period of time. And obviously prior to their written languages, all we have is the archaeological record. Like we don't know anything about, all we know about human prehistory or about civilizations that didn't have a written script is preserved through the archaeological record.
Yeah.
But archaeology is becoming more and more data driven. So, for instance, you can have studies of basically using geographical mapping and looking at the concentrations of different kinds of archaeological records.
Yeah.
So, for instance, like imagine like clay pots, right? You can estimate the size of ancient civilizations by looking at the concentration and density of earthenware.
Oh, interesting.
You can look at GIS, so like the use of GIS, global GIS to basically map old civilizations can be done by GIS archaeology and like using statistical means.
Yeah.
New means of, I don't know if you're familiar with the idea of the Dead Sea Scrolls. Have you heard of the Dead Sea Scrolls?
No.
So this is a set of very ancient texts that are rolled up very tight in papyrus. And I believe that they're from the either the Egyptian era or after the Egyptian era in the Middle East.
Yeah.
And they're buried in these caves. And if you try to unroll them, it just breaks it. Right.
Yeah.
So you just destroy the evidence. And so they've just been sitting there rolled up now for decades and decades and decades.
Oh, wow.
But they contain written language on them. So hypothetically, if we could read them, we could discover so much more about the ancient world.
Yeah.
So there's currently work to use algorithmic means to basically model their folds and try to unfold them digitally.
Wow.
Using sort of modern modeling methods and things like that.
Yeah.
So there's tons of little, like, I don't know, explorations and things like that I think are very interesting.
Oh, that's pretty cool. Do you see yourself some point combine your knowledge of history and data science, or you work on those type of topics?
Good question. I don't know. I think of studying economic systems, studying markets, I think is a kind of a applied data science applied to humanity.
Yeah.
Obviously, the availability of data. I'm not sure if I'll ever be more than a fanboy of just reading about these topics with great interest.
Yeah.
Maybe one domain which I think is also potentially more accessible is genomics and looking at basically the spreading of different kind of the spreading of humanity as measured through changes in genes and genetics. So you can often validate and invalidate different historical records through the study of basically gene prevalence over time.
Yeah.
So it's kind of a trope to talk about how the Mongol invasion resulted in lots and lots of children that were attributable to the Mongol emperors, and Genghis Khan had, however many 100 kids, right? But the truth is, you can actually measure that. You can measure the Mongol invasion by its impact in genetics, by virtue of the fact that many, many, many people in Central Asia, Northern China, and even Eastern Europe have a DNA that is sort of like Northern Asian in origin.
Yeah.
And there's lots of other things that you can sort of like see, history reflected in the study of genetics. And I think that's another domain that is potentially very interesting.
Yeah.
And that's especially with like sites like 23andMe and things like that, where people are becoming more and more aware of their genetic predispositions. It might be interesting to like to dive deep into that and look at historical human migration patterns and things like that.
Yeah. Have you tried 23andMe?
I haven't. No. I'd be interested. Yeah, I could do that. I just haven't bothered to get around to it.
Yeah.
Have you done it?
No, I'm probably just 100% Chinese.
You never know though, because like even Chinese identity is actually very complicated. There's lots of movements inside China.
Yeah.
So, but it's also true that 23andMe is predominantly serving European and American clients. So their ability to draw very like interesting, draw interesting conclusions in Asia, I think is somewhat limited.
Yeah. So in general, what do you think the future of data science will look like, say 5 years, 10 years, or 20 years?
Well, I think, automation is the name of the game, right? So everything about our lives will be more and more automated.
Yeah.
I think the tools available to us will become more and more sophisticated. So for instance, one thing I've noticed just even over the course of the last 2 or 3 years is the novelty has worn off. Like it no longer feels all that cutting edge to talk about deep learning. And this is like in our domain, for instance, a lot of people, for a lot of folks, it's still like very, very far away. But these sorts of things become democratized, right? Knowledge of these things becomes democratized. And that means that the marginal value of knowing something maybe decreases a little bit.
Yeah.
Right. And I think Andrew Ng just recently, tweeted something which to me just struck me, which I thought was just totally accurate, which was like the day of building a company with data science or AI as the forefront thing that you're doing, it's just not happening anymore.
Yeah.
Like you can't, like what you need to do is have an applied business problem.
Exactly.
You need to have a domain in which you want to make a specific impact. And these are just tools in the toolbox to help achieve that effect.
Yeah. I saw someone have a post on LinkedIn. It's pretty funny. Said, I don't care if our business is running by AI or by a hamster, as long as it's working.
Yes.
Right? Yeah.
Right. Yeah. Although, if we could train hamsters to do it, I think it'd be great.
Yeah. And in order to prepare the future of data science, what do you think the new data scientists can do today so they can still have a competitive edge in the future?
I guess my sincere advice to folks is don't become pigeonholed. Learn how things work all the way down.
Yeah.
And I think that often does mean venturing into the territory that is often considered the role of engineers. But I think that knowing how things work at all the layers is extremely important.
All the layers meaning?
Oh, just for instance, like if you're comfortable interacting with your distributed data query engine, you should learn how that query engine works.
Yeah.
Right? You should learn what are the ways that query engines are improving. Right. And I think that there's sort of like two lines of investigation that one can take as a data. Like fundamentally, I think that there's sort of a divide. Like if you are in the position of a data expert, your knowledge should expand in one or both of these directions. The first is you should become technically proficient in your tools, and you should gain a deeper and deeper and deeper and deeper proficiency in your tools.
Yeah.
The other is you should become more and more and more proficient in your domain, in the business domain.
Yeah.
And so that you are somebody who knows about the entire marketplace.
Yeah.
Right. And I fundamentally think that like either of those trajectories can be really fruitful and really wonderful.
Yeah.
Personally, I think I have found myself more interested in the technical things.
Okay.
And I think one of the reasons is because I have an interest in a very broad variety of domains. So the technological solutions can be consistent from domain A to domain B.
Right.
And I think I prefer that ability to be broad rather than feeling like I need to basically just hunker down. Like for instance, I worked at Indeed for a long time. Indeed is in the HR domain. It's about getting people jobs, right? Indeed is a wonderful place to work on that. And my next work was at a social media company. The domain was totally different. Like it was a very different domain of the economy.
Yeah.
But because my focus and interest was more on the technologies, a lot of things were transferable between there.
Yeah.
Whereas I think that had I been just focused purely on the business, things like that, then my area of possible next steps would have been different. Yeah. Not necessarily better or worse, just definitely different.
Yeah.
Yeah.
I also work in the human resource team in Amazon before. It just all the domain knowledge are completely different, and you have to learn that. And then that's sometimes even more important than the tools, the models you use.
Yeah, absolutely. Yeah. I think they're certainly from my early days, my early career to now, the amount that I care about what model has greatly decreased.
Right.
I think that's so much less important than accurately modeling the problem.
Right.
Right. Just actually representing the problem space correctly is so much more frequently a problem than not knowing the right model to use.
Yeah, exactly.
Right.
So how do you translate that business problem into a data science problem?
Right.
Yeah.
Exactly. Yeah.
And for people who are new to the industry, how do you think they can learn to ask better questions to translate this business problem to data science problem?
I mean, I think it's the same way that you learn about being a better engineer, or if you're learning about how your tools work, is ask why. Like try to understand all of the undergirding assumptions.
Yeah.
So if you are kind of formulating a hypothesis, you should deeply interrogate that hypothesis, all of the logical steps that lead you to that hypothesis. And if you find something that's weak, stop, investigate that point, dive deep on that, see if that supports the original assumption.
Right.
I think that's basically the strategy. It's like, don't let yourself be comfortable with too many abstractions. Like take off the abstractions, go and explore. Yeah,
that's great advice. So what is something in your life or in your career that you feel very excited about right now?
I feel excited to be part of a journey in an organization that's like, I think really beefing up our data science potential. And like, not just in data science, but just becoming becoming a group of professionals. And I also feel super excited about the growth that I've seen on my team and like watching people push themselves and be successful.
Yeah.
Like I think that's maybe like a note to kind of like wind up on, is like, it is deeply gratifying to provide somebody with, or I guess to try to work as a manager to create a context where people can learn and can fail, and to set up some loose success criteria, and then to watch people get really good is really fun.
Yeah.
Yeah.
And right now, are you hiring data scientists?
We are, although we haven't yet mentioned my place of employment because of various concerns about, PR and things like that.
Sure.
So unfortunately I have to keep it that way for the duration of this interview because of comm stuff. But yes, if feel free to reach out to me on LinkedIn. Which I think I can share that information.
Okay. And then, so in general, when you're hiring a data scientist, what is the most important quality you're looking for?
Oh, I don't think there's any single quality. I think it is. I actually have a whole essay that I would be happy to share with you on the hiring process. But I think that one should be looking for a multitude of qualities, or I think this domain is a very broad domain, and I think that to hire effectively, an interview process should be looking at competency across a broad set of skills. And I don't think there's any single skill that is dominant.
Okay.
I think that I think that there's the idea of the well-rounded candidate, and then there's the idea of the spiky candidate.
Right.
The spiky candidate might be an amazing executor, just have incredible knowledge in one domain, and have so like at the bar knowledge in other names or other domains. Whereas like the well-rounded candidate might have above, let's say good knowledge across many domains, but isn't sort of an expert in any.
Yeah.
So, but I do think it's important to keep in mind the breadth of that.
And can you give some examples of, you said you're looking at a few things. What are the, say, top 3?
Yeah. So I mean, like the ability to model a business problem, to take a problem from concept down to some sort of driven solution, right? We could call that like maybe the domain expertise, right? The ability to actually put pen to paper, so to speak, but actually produce lines of code that result in a solution. I think that it's very, very important for people to demonstrate that they can do more than just talk about a problem, that they can actually work through a problem. And there's many ways of doing that. We don't need to dive too deep into that. And then probably that, then it becomes a matter of specialization. Is this person specializing as a data engineer? Is this person specializing as like a product analyst like role? Is this person specializing? Is this person sort of a general full stack data scientist? Is this one person doing machine learning engineering? There's all sorts of different sort of modules that one might add in to test specific proficiencies. But the ability to kind of like manipulate data or make judgments, for example, a machine learning engineer probably needs to be able to execute very well and make some decisions about models and what success criteria that they're using to evaluate model A versus model B, and set up a test train split and all that sort of stuff. Whereas a data engineer might be much more concerned about the cardinality of this joining A versus joining B, thinking about how to model, if you have an event stream, how do you create like a state of table at time t representation of that event stream? Like there's all sorts of different questions. So yeah, I think it's very much depends on the specialization.
Yeah. Thanks for sharing that. And before we wrap up, do you have any like books and courses that you really like? You think you wish more data science would read? And learn?
Yeah, I'll give one more book recommendation. And this is, I think, one of my favorites, which is by Andrew Gelman, Data Analysis Using Regression and Multi-Level Hierarchical Models.
Yeah. And are there anything else you would like to talk to our audience? Any learnings or advice you would share for a data science career?
I think we've mined it. We've gotten it all. We've solved all of the
Nice.
Yeah.
So if people want to find you on the internet, do you have a blog, social media? How can people reach out to you?
Let's see. I do have a Twitter account, which I can share with you. I don't remember the name right now, but
you don't remember your Twitter accounts?
I think it's. I don't remember it actually.
Yeah, we'll put it in the notes.
Yeah, yeah. Or on LinkedIn.
Yeah, on LinkedIn. Cool.
Yeah.
Thank you so much.
Yeah, Dalila,
Brian.
pleasure.
Yeah, it was really fun. And I think what we talk about will benefit a lot of people.
I hope so. Thank you.
Thank you.